Hi, good day everyone. So this is our last topic for the subject, the second law of thermodynamics. At the end of this chapter, we will learn the difference between reversible and irreversible processes, the physics behind internal combustion engines, the relationship between heat engines and refrigerators, the second law of thermodynamics, and what is meant by entropy and how to use this concept to analyze thermodynamic processes. Many thermodynamic processes proceed naturally in one direction but not the opposite. For example, heat by itself always flows from a hot body to colder body. So why does the direction of heat flow is from hotter to cooler region? Could it flow from could it flow the other way? Another question is this. It is easy to convert completely mechanical energy into heat, but it but not the reverse. Why not? So why is it that the reverse process, which is the heat, convert it completely to mechanical energy is not possible? So these questions, we need to use the second law of thermodynamics to answer the above questions. So what is second law of thermodynamics din? So unsa gyud ni first second law of thermodynamics? Kabalo naman ta og first law, no? First law is katong the relationship between the internal energy sa iyahang heat ug sa iyahang work. So this is the first law. So ang second law is unsa gyud ni? So second law, unsa gyud ni second law? So we will discuss this in this video. So before we discuss second law, let's first define reversible and irreversible processes. In thermodynamics, a reversible process is a process whose direction can be reversed to return the system to its original state by inducing infinitesimal changes to some property of the system's surroundings. Say, for example, one example of irreversible processes we have the frictionless motion of solids because pwede nimo mabalik ang system to its original state. So usually reversible process kaning mga process o mga system nga walay friction. Kaya ang friction man gud kay mo lose siya og energy, mo lose og energy ang imong system if there is friction. So reversible, it means na your energy walay malose nga energy, dapat kung ibalihon nimo ang process, dapat mabalik siya sa original state. For irreversible process, muna ang gingon gayon ng most or many thermodynamic processes proceed naturally in one direction. So most thermodynamic processes in nature are irreversible, are example of irreversible process. So it can be defined as a process in which the system and surroundings do not return to their original condition once the process is initiated. It is because there are some factors like, for example, friction, nga mo resist sa motion o magkawala ang iyang energy. That is why dili na siya kung imong i-reverse ang process, dili na siya mabalik to its original condition. Say, for example, this one taking an example of an automobile engine that has traveled a distance with the aid of fuel equal to amount X, for example. During the process, the fuel, or for example, gasoline mo gamit, burns to provide energy to the engine, converting itself into smoke and it convert niya into heat energy. And take note, we cannot retrieve the energy lost by the fuel and cannot get back the original form. So, kaning example is an example of an irreversible process. Kaya naamay na, take note, naamay na lost nga energy. And kaning na lost nga energy is dili na nimo siya, never na nimo siya mabalik or makuha pagbalik. Okay? So dili gyud pagbalihon nimo ang process, like for example, ang process ani is na ako'y heat i-convert nimo into work, naagid siya always exhaust, naagid siya always kaning smoke, for example. So di kini mo siya mabalik to original form. So that is irreversible process. Now, we have this disorder of in thermodynamic processes. There is a relationship between the direction of a process and the disorder. Take note, disorder, or call this one as randomness of the resulting state. For example, imagine 1,000 names written on file cards and arranged in alphabetical order, and then gilabay nimo na siya into the air through the alphabetized stack of cards into the air, and they will likely come down in a random disordered state. So, pag itsa nimo na ko'y baraha, for example, pag itsa nimo, then what will happen pagabot sa floor, nagkalatag, disordered ang imuhang mga state o imuhang mga baraha. So that's disorder in a thermodynamic process. So what do you mean by disorder? Disorderliness or randomness, it implies the statement of the second law of thermodynamics. So second law of thermodynamics is all about disorder or randomness of the state. Okay, so we will discuss that later, but before that, we will introduce first these two devices. We call this one as heat engines and refrigerators. So magamit nato ni siya to provide the statement of second law of thermodynamics. So basically, kung muhisgot ko og second law of thermodynamics, always nagi ko example of about heat engines and refrigerators. So what do you mean by heat engines and what do you mean by refrigerators? So let's now go to heat engines. Most of our energy comes from the burning of fossil fuels and from nuclear reactions. They supply energy that is transferred into heat. Okay, energy is converted into heat, and this is directly useful for heating buildings, for cooking, and for chemical processing. But to operate a machine, okay, or to propel a vehicle, we need mechanical energy. Okay, so we need mechanical energy. Thus, it's important to know how are we going to take heat. Okay, saan na to pag-convert ang heat from any source. Source na to is kaning mga fossil fuels or nuclear reactions, and convert it into mechanical energy. Mechanical energy, or we call that one as work. So question is this: kung saan na to pag-convert ang heat into work? Okay, so how to take heat from a source and convert as much of it as possible into mechanical energy or work. This is what happens in gasoline engines, in automobiles, in jet engines, in airplanes, steam turbines, in electric power plants, and many other systems. So basically, kaning mga system, kaning automobiles, airplanes, and so on, kaning mga system is nagamit sila og heat gikan sa source, any source, no? Nagamit sila og heat and then gi-convert nila into work. And take note, you cannot convert totally heat into work. Again, you cannot convert totally heat into work because it defies the second law of thermodynamics. I will discuss that later. Again, you cannot convert completely 100% heat into work because it defies the second law of thermodynamics. Discuss heat engine. What is his heat engine? It is a device that transforms heat into work. So muna ang goal sa heat engine, muna ang definition sa heat engine, converting heat into work or mechanical energy. All motorized vehicles other than purely electric vehicles use heat engines for propulsion. Okay, hybrid vehicles use their internal combustion engines to help charge the batteries for the electric motors. Usually, a quantity of matter inside the engine undergoes inflow and outflow of heat, expansion and compression, and sometimes change of phase. So, unsay nasulod sa imuhang makina, sa imong engine, nadira ang katong inflow of heat, ang pag-absorb sa heat, and then ang pag-reject sa heat. We call that one as outflow of heat. And then there is expansion and compression of piston nga nasa imong engine, and sometimes usahay ang nasa sulod kay mo change ang iyang phase from liquid to gas or what. We call this matter the working substance of the engine. Take note, in internal combustion engines such as those in automobiles, the working substance is a mixture of air and a fuel. So ang fuel nga tong gina consider dire is duha ka buok, gasoline and diesel. Okay, diesel fuel. So unsay kalayan sa duha? Asa may mas nindot, gasoline na ba imong gamit nga fuel or diesel nga fuel imong gamit? Okay, so we will discuss that later. Okay, so this is the schematic energy flow diagram for a heat engine. We have to take note that ang goal sa heat engine is to convert heat absorbed, okay, into work. Naningon ko gaya na you cannot completely convert heat into work because it defies second law of thermodynamics. That is why napay araw nga padulong dira, okay, and we call this one as waste energy or waste heat. Muni ang heat nga gi-reject sa imong heat engine. So dili gid siya totally ma-convert ang heat into work, lagi siya always na siya always kaning waste nga product. So muni karon ang schematic energy flow sa ato ang heat engine. So unsay nahitaboan ni? First, napoy hot reservoir. We have to take note first that simple heat engines operates on a cyclic process. What do you mean by cyclic process? When the process is cyclic, then the internal energy must be equal to zero. So muna ang definition sa cyclic process. So sa heat engine ang nahitabo dire nahitabo sa circle, dire dapat nahitabo ang engine. So ang iyang buhaton kay nag-absorb siya og heat QH, and then this QH will convert into work. Some of it is converted into work and some of it is rejected, and we call that one as QC. Okay, some of it is converted into heat and some of it is rejected to cold reservoir at some temperature Tc. So muni ang basic diagram sa atong heat engine. Always yun nga ngali no na po QH, the direction is na I work na may tabo, and then na apoy waste product or waste heat nga i-reject sa imong system. So makita nato ni siya sa makina sa ato ang sakyanan. So di kay maklaro pero mo ni ang mahitabo sa ato ang sakyanan. And kaning work mo ni ang mag-determine mo ni ang mo determine kung sa kakusog mo dagan imong sakyanan, sa kusog mo propel imong car or what. Depende sa value sa ato ang work. So kung ikaw nagahimo og sakyanan, ang goal yun mo is ipa-increase nimo ang efficiency sa imong sakyanan. And we call that one efficiency as E. Okay? I will discuss that later na siya. So, ang goal is dapat dako kayo ang value sa imong efficiency. And take note, so far, wala pa efficiency equal to 1. Because kung mag-1 na gali na, then it defies the second law of thermodynamics. Wala di efficiency nga equal to 1. I will tanaw na to later ang expression sa atong efficiency. So mura ang point sa heat engine, no? Na point heat. So heat from a source, any source. So in a gasoline engine, ang heat kay gikan sa mixture sa combustion sa air o sa gasolina. Dira gikan ang heat, and then tungod ana nga heat mo propel or mo move na compression expansion sa imong piston, and tungod atong expansion and compression makadugaw work, and then after that na exhaust nga pipe nga mogawas ang imong or mo reject ang na some heat nga mo reject sa imong system. So tan-aw na to na sa usa ka makina in our next na presentation. So mura lang goal, no? Heat engine kay na po Q converted into work but not totally converted into work, na some heat nga mo reject, we call that one as QC. That's heat engine. Now, so muna ang gingon gaya no, efficiency of a heat engine is the fraction of the amount of heat absorbed that is converted to work. So basically, ang heat, ang efficiency, the thermal efficiency of an engine is equal to the ratio between the work done by the engine over the heat absorbed by the engine. And it is equal to this one plus QC plus QH, or one this one. Okay? And this is E cannot be equal to 1 because QC, nagi always QC, right? Sa heat engine, kay nagi kay ma-reject nga QC divided by QH, kani siya is a number not equal to 1. Okay? This is not a number equal to 1 or equal to 0. Okay, so dili siya gyud nga makakuha kag efficiency nga equal to 1. Kay kung makita kag efficiency nga equal to 1, then posible nga ikaw na guro ang pinakadato nga kung karon, no? Kung makakuha ka or maka-invent ka og car na ang efficiency is equal to 1, then probably mas dapat pa ka ni Elon Musk. Okay? But take note, walay efficiency nga equal to 1. It is always less than 1. This is always less than 1. Why? Because kana siya kay modify siya sa second law of thermodynamics. Ngano kay ito? Because si heat kay dili gid siya ma-convert totally into work. Kay kung equal lang ang heat ug ang work, then that is equal to 1. So si heat daw is dili gid siya completely ma-convert into work. Meaning ani, kay why is it nga ang imuhang sakyanan kay nay tambutso, no? Na tanan sakyanan kay namoy tambutso siguro, no? Ano nay tambutso? Because ang tambutso is muna ang place kung asa nimo gi-reject ang heat. Okay? Muna ang mga rejected na heat. Nganong nay tambutso ang isang kasakyanan? Because dira mo gawas ang heat nga gi-reject sa imong system. So kung makita og sakyanan nga walay tambutso, then probably, or makahimo kag sakyanan nga walay tambutso, walay mo-reject na heat, then probably madato ganan. So take note, always your efficiency is always less than 1. Okay? That's heat engine. So for example, a gasoline truck engine takes in 10,000 joules of heat and delivers 2,000 joule of mechanical work per cycle. So muna, no? Nakoy heat QH pero wala tanan na convert into work. So 10,000 ang na-convert lang nga heat into work is only 2,000. So naay sobra nga 8,000. Naay kulang nga 8,000. Ang kaning 8,000 is mo ni ang gi-reject nga heat sa imong heat engine. So a gasoline truck engine takes in 10,000 joules of heat and delivers 2,000 joules of mechanical work per cycle. The heat is obtained by burning gasoline. So asa unsa ang source sa heat? Ang source sa heat is kaning burning of gasoline. With heat of combustion equal to LC, 5 times 10 to the 4 joule per gram. What is the thermal efficiency of this engine? How much heat is discarded in each cycle? If the engine goes through 25 cycles per second, what is its power output in watts in horsepower? How much gasoline is burned in each cycle? Okay, so let's answer this. For letter A, solution. We will first draw the energy diagram, energy flow diagram. So na ako sa heat engine, take note sa itong sa heat engine na ako yung QH, the absorbed heat, which is ang absorbed heat is gikan sa kaning combustion of gasoline, and then convert it to work, and then there will be a heat that is rejected to your heat engine. So muna ang diagram sa imong heat engine karon, where QH is given, this is equal to 10,000 joules, and ang na-convert nga work is only 2,000 joules. It means na the QC is equal to 8,000 joules, right? Since 2,000 lang ang na-convert into work, so ang bilin sa 10,000 which is 8,000 is muna ang imuhang gi-reject nga heat. Muna ang na-reject nga heat sa imong system. Okay, so muna ang energy flow diagram sa ato ang heat engine karon. Question A, find the efficiency. Efficiency is equal to the ratio between work and the heat absorbed, and it is equal to 2000 joules over 10,000 joules. So the efficiency is equal to 0.20, and this will be equal to 20%. So ang imuhang car engine, ang imuhang heat engine kay naa efficiency only 20% na thermal efficiency. Again, walay maglisod ka og kuha og efficiency nga 100% kay kada that. Okay? Always gid siya less than 1. Okay, so this is the efficiency of this heat engine. For letter B, how much heat is discarded in each cycle? So ang gipangita sa B is the QC, which is equal to 8,000 joules. Say kulang, no? The kulang is the negative sign. Okay? Negative sign because QC is always negative. Okay? Since anong negative gani kay ni gawas siya sa imong system. Okay? So na minus 8,000 joules. For letter C, if the engine goes through 25 cycles per second, what's the power output in watts? Okay, power is equal to the work, okay, the work done over the time, right? Power is work over time, no? And since kada cycle, kada second na ako'y 25 ka cycle, meaning 25 ka cycle ang hitabo sa imong engine per second. So therefore power is equal to this, na ako'y work, which is equal to 2,000 joule per cycle. Okay? Kada cycle kay makadan siya og work nga 2,000, which is given, no? Na ako'y 2,000 work joule of mechanical work per cycle. If you multiply this by 25 cycles per second, you will get the power, right? Because this one is na ko'y mag-cancel ang cycle. The remaining unit is na ko'y joule per second, and joule per second is the unit of power. So therefore, na ko'y in every work, 2,000 joules of work per cycle, and then in every second na ko'y 25 cycles, the power of this heat engine is equal to 2,000 times 25, so that will be equal to 50,000 watts or joule per second. Or if you convert this to horsepower, just divide this by 746. Okay, divide lang nyo na sa 746 as 746. Okay. This is in horsepower, this is equal to 67 horsepower. So this will be the power output of this engine that goes through 25 cycles per second. So na 50,000 watts. Okay, for letter D, how much gasoline is burned in each cycle? We know that the heat of combustion LC is equal to 5 times 10 to the 4 joule per kilogram. So for letter D, calculating the mass of the gasoline, how much gasoline is burned. So meaning ang gipangita is ang mass, and using this, the heat for combustion is equal to mass times the LC. The heat here is the heat absorbed, okay, not the heat rejected from the system. So given is QH equal to 10,000 joules and LC is 5 times 10 to the 4. So you can get for mass equal to QH over LC, and this is equal to 10,000 joules over LC na 5 times 10 to the 4 joule per gram. Cancel ang joule, you will get mass in terms of grams. This is equal to 0.20 grams. Okay. So in each cycle, burn ka og gasoline with mass of 0.20 grams. Okay, 0.20 grams. For letter E, how much gasoline is burned per second? So for letter E, kada segundo pila ka gasoline ang mawala or ma-burn sa imong makina. So we know that in every cycle, ma-burn ko og 20 grams per cycle. And we know that in 1 second, given na in 1 second, mutuyok siya og 25 in 1 second. So therefore, kada segundo mo gamit ka og 5 grams. So 0.2 times 25 is 5 grams per second. So in every second, na ako'y 5 ka gramo nga gasolina ang imong ma-burn sa imong heat engine. Okay?